given that the limit as x approaches 3 of f of x equals 2, the limit as x approaches 3 of g of x equals 4, and the limit as x approaches 3 of h of x equals 0, find the following limits if they exist. Let's go through these one at a time. We'll start with the first one, part A. We're looking here at the limit of f of x plus 3 times g of x. I'm not going to say as x approaches 3 because that's true of all of these, and I don't want to say the same thing 30 times in this video, so we'll just say the limit of f of x plus 3 times g of x. Now we know that we have a limit law that says the limit of a sum is the sum of the limits, so we can separate this into the limit of f of x plus the limit of 3 times g of x, but then we also have a rule that says we can pull out that coefficient outside of the limit, and so this is going to become the limit as x approaches 3 of f of x plus 3 times the limit as x approaches 3 of g of x. And we know the values of those limits, so we can plug them in. The limit of f of x is 2, and then plus 3 times the limit of g of x, which is 4. And then we can simply do the math. 3 times 4 is 12, plus 2 is 14. So that limit is 14. The next one has the limit of f of x to the 4th power. And we know we have a limit law that says that we can take that and bring the power outside of the limit. So we can write this as the limit as x approaches 3 of f of x, and then that whole quantity raised to the 4th power. Now we know the limit of f of x here is 2, so this is going to be 2 to the 4th power, which is just 16. All right, things are going well. For part C, we know we have a rule that says if we have the limit of the square root of a function, we can rewrite that as the square root of the limit. So we're going to put the limit on the inside of the square root. And then we can evaluate that limit first. We know the limit as x approaches 3 of g of x is 4. So this will be the square root of 4, which is just 2. Okay. For part D, we know that the limit of a quotient is the quotient of the limits, so long as the limit in the denominator is not equal to 0. And so we can write this. We can also pull that 6 outside of the limit. So this is 6 times the limit as x approaches 3 of f of x over the limit as x approaches 3 of g of x. And then plugging in those limits, we've got 6 times 2 in the numerator and 4 in the denominator, so that's 12 over 4, which simplifies to 3. All right, so for E, if we were to try and split this up and write it as the limit of g of x over h of x, in fact, let's write that out. The limit as x approaches 3 of g of x over the limit as x approaches 3 of h of x. The problem here is that we end up with 4 over 0, which is undefined. And so in this case, we can't actually separate the limits like that. And in fact, the limit does not exist in this situation because we can't divide by 0. It ends up being a little bit more complicated. I don't want to get into it too much. We could have infinite limits. We might have a left-handed limit that's different from a right-handed limit, and they're both infinite. We really don't have enough information to evaluate that more, so in this case, we'll just say the limit does not exist. And then we've got one more, and I'm going to write it down here to give myself a little bit more room. So this is going to be the limit as x approaches 3 of h of x over the limit as x approaches 3 of g of x. and that's going to be 0 over 4, and that we can divide. 0 divided by 4 is 0. So the limit there is just 0. And there we go. There's a lot we can do with combinations of limits if we know the limits using these limit laws.